So we go ahead and also solve and also talk about three exponential equation and log equation. So the first question here is for exponential, and these are one of the most important and interesting questions under exponential when it comes for equations. Okay, so let's try to take step by step and see how we can crack this question. So now we want to understand, we need to understand one thing. So I will write the question which is saying 2 raised to the power 2x plus 1 minus 2x plus 1 plus 1 equal to 2 to the power x. I want us just to go back a bit when we talk about indices. Let's say we have got x to the power 2 times x to the power 3. If the bases are the same, we add the powers. So it will be 2 plus 3, which is going to be 2 plus 3, and then it's going to be 5. Okay, I've given you a hint so you can see what is happening. What if I've got 3 raised to the power x times 3 raised to the power y? Since the bases are the same, if you are multiplying and the bases are the same, you just add the power. So it will be x plus y. So if I have got, let's say I've got 2 raised to the power x plus y, I can take it back like that one. I can say initially that was 2 raised to the power x times 2 raised to the power y, for us to come up with that. Okay, we can see the trend now. Now what if I have been given 2 raised to the power x plus 1, meaning this was 2, or let me just give you this. Yes, meaning this was 2 raised to the power x times 2 raised to the power 1. The bases are the same, then we added the power and it gave us that. So it's more like I'm doing the reverse. So it's basically the same with this 2 raised to the power 2x. So this was 2 raised to the power 2x times 2 raised to the power 1 minus this was also 2 times 2, this was 2 to the power x times 2 raised to the power 1 plus 1 being equal to 2 raised to the power x. So that if I want, I can take it back there. The powers, the bases are the same, you add the powers, so it will be 2 raised to the power 2 plus 1. Okay, any number to the power 1 is the number itself, so it's basically the same as, I can write 2, then I say 2 raised to the power 2x minus, here I can also put 2, then 2 raised to the power that plus 1 being equal to 2 raised to the power that. Now at this point, when you reach at this point, I have to so I have to say let y be equal to 2 raised to the power x. So meaning that where there is 2 to the power x, let's replace it with y. We see what we're going to have. So we have 2 to this is 2 to the power 2x, meaning that it is y, then it is squared because of these 2, minus 2y plus 1, it will be equal to, this will be replaced by y, 2y, oh, just y, sorry, because we are replacing um, 2 to the power x with y. Then I can shift this to go to the left side, so it will be 2xy minus 2y minus this plus 1 equal to 0, and of which is going to give me 2y squared minus 3y plus 1 equal to 0. Now we can clearly see that that is a quadratic equation. That's a quadratic equation, so the product is 2 times 1 positive 2, the sum negative 3, factors will be negative 2 and negative 1, so that negative 2 times negative 1, it will definitely give me positive 2, negative 2 minus 1 negative 3. So this is my quadratic equation, so it will be 2y squared minus 2y minus y plus 1 being equal to 0. So it will be 2y open bracket, I'm factoring out 2y, y minus 1, factor out 1, y minus 1 equal to 0. 2y minus 1 and y minus 1. If you remember the question we were solving under trig equation, it was basically the same as this. So we have 2y minus 1 equal to 0, y minus 1 equal to 0. Shift 1 to the other side, 2y will be equal to 1 divided by 2 by 2, y will be equal to 1 half. Again, y will be equal to 1. We have these two answers. But we want to find the value of x. We want to solve for x, and this is just y. So how can we find the value of x? You go back to the equation which you just manipulated yourself. We said that let y be equal to 2x. It's the same as I say 2 raised to the power x is equal to y. So the first y, we have found that it is half. So I'll put half. So how can I find that? And I know, guys, that I definitely know that if I have got 1 over 2, it's basically the same as 2 raised to the power negative 1. Okay? It's 2 raised to the power negative 1. Or, if you don't believe, if I say 1 over x squared, it's the same as x to the power negative 2. So meaning that this is 2 to the power x, then 2 raised to the power negative 1. So the bases are the same, you can cancel the bases and equate the power equal to each other. Therefore, x is equal to negative 1. That's the first answer for x. Okay. Another one, we found 1. So let's see. 2 raised to the power x is equal to 1. Now, if you can't make the base to be the same, you introduce natural log, ln, in front. So it will be ln 2 of x is equal to ln 1. So you drop the power. You know the property of log allows us to shift the power to be in front. So it will be x ln 2 equal to ln 1. But one thing we should know is that log 1 regardless of any base is 0. Ln 1 regardless of any base is also 0. Then we have got ln 2 equal to 0. Divide both sides by ln 2, another value of x is 0 over ln 2, which is 0. So those are my values. If you want, we can prove to see if the answer is correct. Let's start with negative 1. So we have 2. So if I have got negative 1 here, and it's going to be negative 1 times 2, it will be negative 2 plus 1. Then minus 2 raised to the power neg 1 plus 1 plus 1 being equal to 2 raised to the power negative 1, like that. So this will be 2 raised to the power negative 1 minus, this is going to be 2 to the power 0. Any number to the power 0 is 1 plus 1 being equal to 2 raised to the power negative 1. And we know that these ones is going to give us 0. So we end up having negative 1, 2 to the power negative 1 is equal to 2 to the power negative 1, which is the same. So it's both 1 over 2, 1 over 2. Now, if I want also to replace 0, you will discover that it's going to be the same. So you can try it out. Now, let's go and solve now for log. One thing we need to understand when we're talking about log is we have this, and this is also, it is in base 3. And also there's another guy here which is also in base 3. So these, as long as the bases are the same, take them so that they should be together to one side. So I'm going to shift this to go to the other side. Okay, so I'll say log base 3 of x plus 1 minus 2 log x minus 1, like that. So this should be equal to 1. Now, for me to make them to be the same, I need to find a way on how to eliminate these two in front. The property of log allows us to shift what is in front to be the power. So it is going to be log base 3 of x plus 1 minus log of x minus 1 is base 3 of x minus 1 all the way raised to the power 2. It should be equal to 1. Reaching at this point, now if you have got the same base, if we have log, let's say regardless of any, the base is the same, plus log b. So this is going to be log that, in this case, when the base, when they have not included the base, meaning that the base is 10. Then you multiply what is inside. So in this case, it's going to be a times b. If you have got log of a minus log b, this is, if there is minus and the base is the same, you divide. The one which is going to be on the denominator is the one carrying negative, like that. Okay, so in a case where you have been given, it is log base 2 of x plus log then x minus 1 base 2. This is the same as log base 2 of x times x minus 1, like that. Okay, so now it's the same principle which I'm going to follow here. Because there's minus, this is going to be on the denominator. So now we have log base 3 of x plus 1 divided by x minus 1 raised to the power 2 being equal to 1. Now when we do that, one thing we should know is that if I have got log base 2 of x minus 1 being equal to 3, what we do is you get the base raised to the power what is outside is equal to what is inside. You change it now from log to exponential. Okay, so it's going to be 2 raised to the power 3 is equal to x minus 1. Okay, what if I have a different one? Let's say you have log of maybe 3 of x minus 1 squared is equal to 7. So you say 3 raised to the power 7 being equal to x minus 1 raised to the power 2. Then you solve for x from there. So we can clearly see that it's basically the same principle which is going to help us here. So we have got the base is 3. Okay, the base is 3. Outside we have got 1. So it is 3 raised to the power 1 is equal to what is inside, everything here, what is inside, which is x plus 1 divided by x minus 1 squared. So now we can expand x minus 1 squared, which is the same as x minus 1. They come, we bring them twice. X times x is x squared. X times 1 is negative x. Negative x times that is that. Then we have that. So we have this. Then 3 raised to a power, I can now get rid of this. I create space. 3 raised to the power 1 is just 3 being equal to x plus 1 divided by x squared minus 2x plus 1. Now we can cross multiply. So 3 times the x squared is 3x squared minus, that is going to give me 6x, then plus 3 being equal to x plus 1. Since there is squared and there is a number with just x, it's a quadratic equation. Shift these two to the other side. So if you shift them to the other side, it's going to be 3x squared minus 6x, okay, minus x. I've shifted x now, then plus 3 minus 1 equal to 0. Then another thing that we have to take note is so it will be 3x squared minus 7x plus 2 being equal to 0. That is now my quadratic equation. So again, I'll get rid of this to create space, everything here. We can clearly see that this is factorizable. The product is 3 times 2, which is 6, positive 6. The sum is negative 7. What will be the factors? The factors should be negative 6 and negative 1, because negative 6 minus 1, it is negative 7. Negative 6 times negative 1, it is positive 6. So therefore, these are the factors we are going to use. So we'll have 3x squared minus, 6x minus x plus 2 being equal to 0. Factor out 3x and I'll remain with x minus 2. Here factor out negative 1, I'll remain with x minus 2 being equal to 0. So I'll remain with 3x minus 1, then x minus 2 being equal to 0. So 3x minus 1 is equal to 0, and x minus 2 is equal to 0. So if I shift 1 to the other side, it will be 3x is equal to 1 divided by 3x being equal to 1 over 3. That is 1x which I have found, which is 1 over 3. The other one, if I shift 2 to negative 2 to the other side, x will be equal to 2. So I've got two values. But whenever you are dealing with equations involving log, you need to be very much careful, because you can never have log of negative. This is undefined. For exponential, it's okay. You can find the answers and don't even test them. It's fine. Those are the final answers. But log has got what we call extraneous solutions. You have solved that it's a part of solution, but if you prove it, it's going to give you undefined. That's not part of the solution. Now we have to check our answers, and don't forget that. Are these both the solutions of this equation? Let's see. So we have log, base 3. Let's start with half. 1 over, we have that, and this is going to give me positive. So I'm going to prove where there is log on. This is going to give me positive because it's plus. I'm okay with that. Let's go to another log, which is base 3. Then we have got 1 over 3 minus 1. So 1 over 3 minus 1, is it going to give me positive? Let's see. So here we have 1, then here we have 3. So it will give me negative 2 over 3. So definitely if I have got log of negative, I have got negative what? Negative 2. So here there is 2. Let's not forget. Initially, if I'm to make things simple, this is basically the same as just shifting 2 to go to the other side. So I'll have log base 3 of 1 over 3 minus 1 squared. So log base 3. Then here now I have negative 2 over 3. But it's because it is squared. If I square it, it's going to be log base 3 of 4 over 9, which I don't have a problem with that, It's now positive, meaning that is part of the solution. So x is equal to 1 over 3 is indeed part of the solution. But in a case where we didn't have squared here, if this was just log of 3, then negative 2 over 3, would have said this is not part of the solution. So be careful on that one, because we have 2 in front, and that 2, when we bring it on top to be the power, any negative is going to be positive. If you square negative, is positive. When I plug in 2 where there is x, here is going to give me 3, positive 3. Here is going to give me 2, or it's going to give me positive 1, which I don't have a problem. So indeed, x is equal to 2 is indeed part of the solution. So both x is equal to 1 over 3 and x is equal to 2 are the solutions, are the real solutions for this equation. But in a case where you plug in, then you get a negative, then that is not part of the solution. That is very important. Take note of that. Okay, so that is it for the equations of log and exponential. Okay,